Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Quadsumes by Senny K. I said quad a little too early there. Here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have a sum dot, where digits in cells touching a gold sum dot must sum to the indicated total. Digits may repeat if allowed by other rules. So the digits in cells, so basically the 4 cells surrounding a gold sum dot, which I think all of these are, must sum to the indicated total. So you could have something like, say, 3761, and this would be valid. Or I guess you could have something like 4661, and this would be valid because the cells surrounding, or the digits touching this gold sum or surrounding this gold sum add up to 17, which is the sum here. Also, we also have the quadruples rule, where digits in a sum dot must appear within the 4 surrounding cells. So that means in addition to having this add up to these 4 cells adding up to 17, they would also actually have to have a 1 and a 7 in the 4 surrounding cells. So therefore, the one that I was doing, which is 3617, would work, whereas 1466 does not work because we have a 7 surrounding this sum dot and a 1 surrounding this sum dot. So the numbers, or actually I guess the digits inside these sum dots do double duty. They form a 2-digit number, basically, which the 4 surrounding cells must add up to, and they also are the digits which also must appear at least once in the 4 surrounding cells around the sum dot, which is why these are called quadsumes, or maybe quadsums. Oh, it's quadsums, right? Like 4 sums or 2 sums or something along those lines. So it's okay. So it's quadsums, not sumes. Shouldn't it? Well, it should either be spelled SOMES or SUMS. That's why I thought it was quadsumes, because the E at the end usually makes the vowel before it, if it has a consonant in between, a long sounding consonant or vowel. Huh. Anyways. Well, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. I don't know. Okay. 27. Yeah, that's the largest one. So 27 must include a 2 and a 7 in it. That adds up to 9. 27 minus 9 is guaranteed to be 18, which has to be 2 specific 9s, right? So this has to be a 279 with a guaranteed 9 in one of these and a guaranteed 9 in the other one. So we're going to mark those both as red. I think we have something actually... Yeah, actually, I've done something similar before to this. So I've seen, actually, I guess I've done this puzzle type one time before, because I've seen something like this. I guess, yeah. So anytime you have 2 as a required digit and 6, or another digit, you necessarily have to have So since if 2 is the tens digit, you necessarily have to have the ones digit be there, right? Which means 2 plus 2 other digits must equal 20, right? Because 2 is the tens digit. Well, the only way you can have that happen is if you have 2, 9, and 9. So any 20 clue here must be 2 with 2 nines and the ones digit. So this is 2 with 2 nines, so 2 with 2 nines and a 6. This has to be 2 with 2 nines and an 8. This must be 2 with 2 nines and a 5. Okay. So therefore, we are guaranteed, we know where all the nines are in rows 1, 2, 3, 4, 5, 6, 7, and 8, and 9. Which means, and we also know where nines are in columns 1, 2, 3, 4, 6, 7, 8, 9. Because we're guaranteed there has to be a 9 here, there has to be a 9 here, there has to be a 9, sorry, there has to be 2 nines in each of these sets to add up to 20. And therefore that leaves this as a 9 here. Because there's no other place for the 9s because they're eliminated in the central box. Here, because there's guaranteed 9 here. Here, because there's guaranteed 9 here. Here, because there's guaranteed 9 here. And here, because there's guaranteed 9 there. Interesting. So this has to have a 1 and a 6 surrounding it. This has to have a 1 and a 5 surrounding this. So it's the same thing, actually, with tens, right? Anytime you have a 1 in the tens digit, the 1, the ones digit, obviously, is going to match the ones digit in the 2-digit number. And the 1 plus 2 other digits must add up to 10, which means the other 2 digits must add up to 9. So this cannot be 5, this can't be 6, so they have to be one of the 2 other digits which add up to 9. So you're guaranteed 9 cannot be here, 9 cannot be here. Well, where is 9 then in one of these 2 cells? It has to be here, which eliminates 9 from being here, so this is 9. And same here. This must be 9 here, and this must be 9 here, because this cannot be 9 to add up to 9. 9 plus another digit is never going to add up to 9 unless it's 0, and 0 is not allowed in normal Sudoku. So this can't be 6 here. So since this can't be 6 here, this must be 9 here, which means this can't be 9, so that's 9. So this is 2 or 7. But this could be 9, or it's 2 or 8. But, okay, so then 5, well, okay, so can you ever have an 8 around a teen which doesn't have 18? I think the answer to that... Oh, it could be. If you have 1 on the other side, right? It doesn't work if they're of the cell surrounding the sum dot is all in the same box. But if you go across region or box lines or region lines, then you could have 2 1s, right? But you cannot have 8. This can't be 8 though, right? Because that would require 9 to be there surrounding this. Okay, so 9 in this box has to be surrounding this quad, so this cannot be 9. Which means where's the 9 then in one of these 2 cells? It must be here. So this is 9, which makes this 9. So this is not 9 here. Okay, so then we can remove all the reds. So this cannot be... Okay, well, we already know this has to be 9. This guarantees has a 5 around it. This could be 1, 8 as a double pair here. Surrounding this dot has to be 1 with 2 or 7, and then 6. So this must be a 1, 2, 6, 7 quadruplet, which eliminates 1, 2, 6, 7 in the rest of the box. So this has to be 3, 4, 5, and 8. Surrounding this quad is a 1. So we're guaranteed a 1 in surrounding this quad and a 1 surrounding this quad, which means we have guaranteed 2 1s already in columns 7 and 8, which eliminates 1s in the rest of the column. So this cannot be 1 here. Where is the 1 in this upper left-hand box? It must be one of those two. So right, 1 has to be one of these 3. Where is 5? Okay, so we are guaranteed a 5 in one of these 2 cells because it must surround the quad. We are guaranteed a 5 in one of these 4 cells, which means we have a guaranteed 5 in... We have 2 guaranteed 5s already in rows 6 and 7, which eliminates 5 in the rest of the row. So this cannot be 5. It's 3, 4, and 8. So this has to be 3, 4, 8 as a triplet, which eliminates 3, 4, 8 in the rest of the box. So this is 5 there. That means the remaining digits in row 6 have to be 1, 2, 5, 6, and 7. Okay. We are guaranteed these cannot be 5, though, because if there was a 5... Again, we have a guaranteed 5 in rows 6 and 7 around this quad and around this quad. We have actually a guaranteed 1 surrounding one of these quads and then one of these quads, which eliminates 1 in the rest of rows 6 and 7. So this can't be 1, and this can't be 1. Okay. So this cannot be 2 sets of 1 and 8 surrounding this. In surrounding this quad, we have a guaranteed 6. Surrounding this quad, we have a guaranteed 6. So that's 2 guaranteed 6s in column 3 and 4 already, which eliminates 6 in the rest of the column. So these can't be 6, which means we have a guaranteed 6 in row 6 here. We also have a guaranteed 1 here and a guaranteed 1 here. Okay, so yeah, we want to have places for the 1s. Be there and there. Has to be here and here. Which means the 1 in column 6 and 7 cannot have a 1. The rest of the column. So this can't be 1, which means one of these two is a 1 here. So this cannot, we know none of these blue areas can contain an 8. Because there's only one, we know there's a guaranteed only 1, 1 in these cells. Right? Also, this is 2 or 6, which must add up with another digit to add up to 9. So the remaining digits in around this quad are 1 and 5 guaranteed, and then 2 with 7, or 6 with 3. Okay. We have a guaranteed 7, 7 in row 3 and 4 around these quads, which eliminates 7 in the rest of the quad. So this cannot, or rest of the row, so this cannot be 7. We also have a guaranteed 1 here and a guaranteed 1 here. But this cannot be 1 because we have a guaranteed 1 here and a guaranteed 1 here. So this is obviously not a guaranteed 1. So this can't be a guaranteed 1 because it must be 2 or 5. So one of these two must be surrounding this, which means this cannot be 1 there. And we have 1 guaranteed there. Okay. Okay. As I said earlier, around these quads, we cannot have another 1-8 pair to add up to 9. Because we have guaranteed 1 here and a guaranteed 1 here, which means this cannot contain 2 1s. It must have just 1 1, and the other 6 must be there. And so then the 2 digits must add up to 9 without a 1. Another 1. So that's why 8 cannot appear around this quad and this quad and this quad here. But 8 could appear here because as the 1's digit, it has to be there. 8 cannot appear any of these cells. So this is blue there. This is blue here. This can't be blue here. The blue has to be one of those 3. So this must then be 1 and 5, and the other 2 digits must add up to 9. And we have 2 and 7 as the only possibility, so this must be a 2-7 pair. So then this is 1, 2, 5, and 7 also. Interesting. You could have 3 or 4 there. Okay, so this cannot be 4, because we have 1 and 8 definitely surrounding this. If you had 4, you would have to guarantee a 5 surrounding this quad, but then we'd have 3 5s in rows 6 and 7, and that's not allowed. You can only have 2 digits in 2 rows, right? Because you can have only 1 digit per row. So this cannot be 4 here. So this is 3 or 8. If it's 8, then you have to use some other combination. So this has to be either 1, 8, and 3 with 6, or 2 and 7 together. Because, so 4 has to be one of these two. Okay, so 6 is guaranteed to be one of these in one of these quads and one of these quads, which means this can never be 6. This can't be 6 because of the same problem, and this can't be 6 because to surround this quad, you have to have 2 and 5 with 2 9s. So this has to be a 6 here, because this can't be 6 and this can't be 6. So this is 6 here, which means this is not the 1. Where is the 1 surrounding this quad? Again, it cannot be here because this is guaranteed to have a 1, and this is guaranteed to have a 1, which counts for all the 1s in column 3 and 4. So this must be 1 here, and therefore this can't be 1, this can't be 1. And we can't have 1 surrounding any more of this. That eliminates 1 from being here. So this can't be 1 here. There's no 1 here. So 1, again, cannot be any of these. We are guaranteed one of these two as a 1. This is 2, 5, 7 then as a triplet, which eliminates 2, 5, 7 in the rest of the row. So this cannot be 2 and 7. Which means this is 1, 6, or 8. Well, we can't have 2 or 7 here, because 2 and 7 must add up with 2 or 7 to add up to 9, which when added with 1 gives you the 10s. So this cannot be 2 or 7, it's 6, which eliminates 6 in the rest of around the quad. So this is 1, 8 as a... this could be 3 also here. So this could be 3 here. We don't know. Okay, I almost made a mistake there. But We avoided that. We know one of these two is 7, so this can never be 7 here, because again, the other remaining digits must add up to 9, and one of them must be 2, one of them must be 7. Remaining digits in row 7, then cannot be 1, cannot be 2, 5, 7, it's 3, 4, 6, 8. Okay. Okay, so this can't be 1. So this digit plus the other digit, and cannot be 9. So this digit plus the other digit must add up to 9. So it cannot be 8 here. It could be 3, 6. So this could be 1, 3, 6, 8. It cannot be 8. There's no 8 here. So 8 has to be one of these two, because this cannot be 8 and 1 with the 1. Because that would be a repeat in this box. So you could have 1, 3 here. And then this would be... could be 4 and 5. Or it's 1, 3, 6. Okay. This is 2 and 8. One of these is 7. We already know that. This is 3 or 5, which is neither 1 nor 6. So where is 1 and 6 here? 1 can't be here because of 1 in the box, or 1 in the column. And this can't be 1, or this can't be 6 because 6 has to be surrounding this. And this adds up with another digit to add up to 9, which would make that 6 with 3, and 2 and 7. So 6 can't be either of these or this, so this must be a 1-6 pair here. Okay. That eliminates 1 and 6 in the rest of the column. This can't be 6, it's 2, which makes this 6 there to surround the quad. So this must be 1, 3, 5, and 6 here to add up to 15. This 2 eliminates 2 here. So this is 5, which makes this 2, which makes this 5. Therefore, this can't be 5 or 2. This is 7. This can't be 5 or 7. It's 2. This can't be 2, so it's 7 there. Okay. This is 6 here, which eliminates 6 in the rest of the row. So to surround this 6 being around here, it must be 6 here, and this must be 1. So this is obviously not the blue. 6 eliminates 6 here, so that's 1 and is the blue, so this is not blue there. This 1 eliminates blue from being there, so one of these must be 1 here, which means, oh yeah, this couldn't be 1 either, because we have 2 1s guaranteed around these quads. So 6 eliminates 6 here, so it's 1 and 6. One of these is 1 here. So this is 17, and therefore it must be... we have to have 1 and 7 surrounding it, so it's 1, 3, 7 then. And this can't be 1 or 7. That makes this 3, which means this must be a 1, 7 pair here. This is 3, 5, and so this must be the 1s surrounding this quad. 3 eliminates 3 here. 8, again, remaining digits in the central box are 2, 4, 8. 2 cannot be here because of 2 in the column. This can't be 8 because, again, we have all the 8s accounted for in columns 6 and 7 around these quads. What else do we have? This 1, 7 pair eliminates 1 and 7 in the rest of the row. So that means this can't be 7 there. I've got hair in my mouth. I don't know where it came from. That's 2, which makes this 7. Which eliminates 7 here, so that's 2, which makes this 4. That makes that 8, so therefore this is 2 in the central box. 2 eliminates 2 here, so it's 8, which eliminates 8 here, so it's 2 to add up to 28. 8 eliminates 8 here, so it's 3, 1, and 8, which eliminates 8 in the rest of the row. Therefore, we have 1, 9 here, so this cannot be 1 here. This is not the blue, so this blue eliminates blue here, and eliminates blue here. So this becomes 7, That's 1, and that leaves 4 and 8 remaining in row 3. So again, this must be 3 and 6, or 4 and 5, adding up to 9. This can't be 1 here, so 1 has to be here in column 9. This is 1, 2, 6. That's 9 plus 7 adds up to 16. So this is 7, and that makes this a 3. We have 1 and 6, so it cannot be 2 5s anymore here because they are in the same column. So this must be 3. Wait, it'd be 5 and 4. Sorry. So this cannot be 3 and 6 because this can't be 3 or 6. So this must be 5, which makes this 4. 5 eliminates 5 here, so it's 3. Remaining digits are 5 and 8 in row 4. This can't be 5 because of 5 in the column, so this is 8. That's 5. 8 eliminates 8 here, so it's 4 and 8. So let's just double check these. I think we have almost all of them filled out. So 3 eliminates 3 here. So 1, 3, so 1, 3, 6 adds up to 10 plus 5 is 15. 9 and 9. And 2 add up to 20 plus 6 is 26. 1, 4, 5 adds up to 10 plus 6 is 16. 1, 3, 6 plus 7 is 17. 1, 2, 7 plus 6 is 16. 2, 9, 9 is 20 plus 7 is 27. 1, 3, 6 is 10 plus 8 is 18. 1, 2, 7 is 10 plus 6 is 16. 2, 9, 9 is 20 plus 5 is 25. 2, 9, 9 plus is 20 plus 8 is 28. And 1, 9 plus 3, 6 or 4, 5 add up to 19. So now the rest we can sort of do with Sudoku. This is the only thing that we have that's not normal Sudoku. 2 cannot be here in this upper left-hand box because of 2 in the row. So 2 has to be here. We have 8 2s. We know where the last 2 has to be. It has to be there. 1s, we're still kind of... we don't have any restrictions here. Let's do this upper left-hand box. We're left with 7 and 8. This can't be 8 because of 8 in the column. So this has to be 7, which makes that 8. In column 1, we are left with 1 and 6. That's not helpful. Column 2, we are left with 4 and 7. Which is not helpful. Column 3, we are left with 3 and 8. And 8 cannot be here because of 8 in the row. So this is 3, that's 8. Remaining digits in column 4 are 3 and 4. This can't be 3 because of 3 in the row, so this is 4. That's 3. 4 eliminates 4 here, so it's 7 and 4. 3 eliminates 3 here. So this cannot be 3 and 6 there. But this could still be 3. This 3, 4 eliminates 3, 4 here. So this is 6 here. So this cannot be 6 here. Remaining digits in column 6, we have 5 and 7, and this can't be 7 because of 7 in the row, so this is 5, this is 7. Remaining digits in column 7 are 4 and 5. This can't be 5 because of 5 in the row, so this is 4, that's 5. Remaining digits in row 1, we have 3 and 6. 6 can't be here because of 6 in the column, so this is 3, which makes this 6. So this cannot be 3 and 6 adding up to 9. It must be 4 and 5. Which eliminates 4 here, so it's 8 and 4. 4 eliminates 4 here, so it's 3. Remaining digit in column 8 is a 3. Remaining digit in this upper right-hand box is an 8, which leaves this digit as a 4. Remaining digits in column 9 are 6 and 7. This can't be 7 because of 7 in the row, so that's 6, which makes that 7. 6 eliminates 6 here. So that's 1 and 6, which forces this to be 1, and this to be a 5. Yeah, fairly... yeah, I mean, I've actually done a puzzle like this before, so that's why I knew this immediately was 9 and 9 here, around the 20s. I actually didn't realize that this was this type of clue, so I think I've done one of these before and showed it. I think it was even on Learn How to Sudoku. Maybe it wasn't. Maybe it was just a normal puzzle. Either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.